Suppose this is the code that is given to us. Fine. So now let us not much worry about what exactly this code is doing. But side by side, like if at all, say we have to translate this, what should be the procedure that we need to apply? So I'm trying to now concentrate upon what you can call it as the actual process of translation. Okay, in more detail. So this is a code that you have, and we are going to make use of this code rather to talk about the translation procedure. Fine. So let us say this code is given to us. Now we know that what would be available with us. What different things would be available with us? Can somebody, what would be the static data that would be available with us? So we have opcode table, correct? We have register info in some form, correct? Then we have information about program counter, which is initially program counter, or you can call it as instruction pointer. This is actually equal to 0. Fine. We have this information. Correct. And we are assuming that we are implementing a 2-pass assembler. Correct. And we have this code available with us. Correct. And this is what we have to translate. Now, what should be the procedure that we are going to apply? Let us try to see. So we saw initially that whether we have been given an input file there. So you are going to input like while you execute a code, say for example, if you see, you are going to write like this. So say for example, if you write a similar and your code, your input would be like this. Fine. So that means you are going to open this particular file. And like you are going to read that, you will start reading that file from this source file, with assumption that your LOC is 0, means line of what you can call it as program counter, LC location counter, program counter, or instruction pointer is 0. So you can add here location counter, program counter, or instruction pointer to be 0. Now, next thing that you are going to see is like assumption here is like we are having different elements through the code, correct? So first of all, we got in the code, we got this line section.data, correct? Then we identified, yes, now we are going to see the data. First of all, I always checked whether it is it a end of file. If it is not end of file, then I will continue reading the line. So I got section.data. So I identified that yes, now my data section is there. Then I will check whether is label defined. So is this a label? For us, it is an identifier, correct? For us, it is an identifier. Now what we will do is we will try to search this into the symbol table. Now initially in the file that we have here, what are the code that you have? This is a static table. This is also available in a static form. So you may see that it is either used at runtime through a file mode, or there could be some other mechanism applied always. Correct. So it depends what kind of procedure you are following there. So now you are like you have symbol table also, which initially is empty. Now you got first symbol here. You got array. Now what exactly you should do? You should try to verify whether my symbol table contains that label or not. So you definitely will be searching this symbol table. Now symbol table is empty. Now this symbol table is modified. Correct. A symbol table is modified. That means what? You are going to enter name of that symbol. And if you recall, we saw the structure of the table, correct? So there we saw defined undefined status. So now we got, as we got this array as a part of my code in like, okay, sorry, I missed it. So let me minimize this. Yeah. So as I saw array as a part here, so that means this is defined. So as it is in the data section, so I will try to modify my symbol table saying that definition found. Correct. Then I will appropriately add the values as per the requirement of the symbol table. Correct. As per requirement of the symbol table. Now next thing what I have to do is like I have to really work out now uh, with respect to the symbol. What exactly I had? I had a symbol table identified. Sorry, I had a symbol table modified. Correct. So symbol table entry is added. Now I will try to determine what is the size of it because I have to modify my symbol table and my symbol table contains what? Sorry, my code contains what is DD. So I will try to put these values there. Now I will identify how many values are there. So let me find out the size. Size would be what? 1, 2, 3, 4, 5, 6 values are there. 6 multiplied by 4. So 24. Then I will apply that size there because I have to modify uh, values here. Values I mean to say the addresses here. Say for example, if I see this code, say nasm dash felf 32 dash l p.lst and this code. If I check my p.lst, now you may see here this address should be changed. Now I have like what I identified was it is 24 because 1 4 plus 4 plus 4 plus 4 plus 4 plus 4. So 6 values. That's why 24 considering this. So my next address for MSG should change. It should be taken as 18. Correct? If I convert that to say for example 24 to hex, then I should get 18. And that's why next address is this. So I have to modify that location counter. Now you will identify that we are using location counter. So for example, location counter I will use always for symbol table. I will use instruction pointer or program counter for in text section. Now this location counter is used through the symbol table with LC1 for text section, sorry, for data section. Say I will use LC2 say for RO data. Sorry. RO data and I will use L3, LC3 because I will require values for each of them to be 0. So if you see this LST, you will identify that for section.bss also we are starting at 0. Correct. For section.data we are starting at 0. That's why we need to have separate location counters for each of the sections. So this is our assumption that I am using this different values. If I don't have RO data written in my code, then ultimately I'm not going to make use of LC3. And I have program counter or instruction pointer. Like if I try to execute this code, say for example, let me remove this. Dash M32 dash G dash app dwarf. So I will write gdb./.out. Now if I see, if I display this EIP, which is my program counter. So if I say breakpoint main, then when I say run, this is the address because I have set breakpoint to main. That's why this is the address of main. Now when I execute next line or next instruction, I can see that it is getting manipulated. It was earlier B0. Now I am getting BA. OK, when I say again NI, my instruction pointer is changing. So this EIP is the one that I am talking here about. from text section. Okay, now we are not worrying about this. So we assume that we are reading symbol table. So we are using this LCLC. Correct. Now we will go to next line. So with assumption that these values are populated in my symbol table, I saw next thing. So I got MSG. Now this is a label. So because it is on next line. So I will try to search this MSG into my symbol table. Now if I identify that is not available there, now my next address should be computed. How I computed the next address? So the way that I showed you that 24 was counted in that LST. So see, we started with this. So these 4 plus 4 plus 4 plus 4. That's how we took 24 there. Like these are the 6 values, correct? 3, 4, 5, 6. Correct. And we are having DD here. So each number is requiring 4 bytes to store. So that's why 6 multiplied by 4, 24. So that was the size, and that's what we added there. So that like while my this LC1 is getting manipulated, this LC1 initially was LC1 was 0. Now LC1 would be representing after I've added values for my first symbol called array. Now my next pointing address is 24. That means actually it would be 18 if I consider hex. Correct? Are you with me?
Yes, sir.
Okay. Now side by side, I actually would be creating this translation for each of the number. So 1110 was converted here. Then 220 was converted here. Then 330 was converted here. Then so on. So each number got converted there in some form. Okay, depending upon how many bytes are required there. Correct. So we saw here for this storing this number, it was say expecting 4 bytes. So what actually NASM does? NASM converts this number to hex and writes in Little Indian notation. You can use 0000006E. That's okay. That means you are following Big Indian notation. If you are writing through Little Indian notation, okay, then you have to make use of this mechanism. So this is to be done. Why? Then after that only you are going to reach to next line and repeat this process until you do not find out any other alternative. So now we got this MSG. So we searched that entry into the table, symbol table. We could not find it. So we have added that MSG there in the symbol table. Now we have 2 entries in the symbol table. So first address was 00, second address was 24. Correct. Now if at all if I have third value, then I will try to see how many bytes are required. So I will compute each how many characters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Correct. So it took 16 bytes. So that's why now if at all I have third variable, then its starting address would be 21, 22, 23, 24, 25, 26, 27, 28 should be the address. Okay, there. So let us try saying whether are we going to get it. Now let me try translating this. Let me generate that LST. So let us see what is the value. So you can see now it is 28 because we computed here 21, 22, 23, 24, 25, 26, 27. That's why now next address is at 28. So ultimately what will happen? That means like earlier it was say when we say 24, 24 plus those many characters. 5, 6, 24, 25, 26, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means next address would be 40. Correct for it. So ultimately you have to convert that number appropriately as per your requirement. You can keep that in decimal too, not a problem. I don't mind if you are keeping that in decimal. So ultimately my next value would be manipulated. Now, I got it 28. I haven't computed this in decimal, but let us say for through X, I got that as 28. Correct? This one. So this is how I am going to make use of LC1. Now, next thing would be like I will go through the code again. Now I got section.bss. Now suddenly I have to initialize this L3, LC3. So now my LC3 will be coming into picture. Correct. Now LC3 initially is 0. So I got first value. I got first value. I got sum here. So what my responsibility is, check into symbol table whether sum is available there. So we identified, we found it is not available. So that's why now we are going to see what happens. Like treatment is different. Now we have to convert in different form. Raise D. So you have to specifically write reserve how many bytes. So we are saying 4. On what basis? We have a counter to be 1. How many is 1? And reserve to be a double. That means 4. That's why this 4. So automatically now that LC3 should point to 4 now because it will be requiring 0, 1, 2, 3 as 4 bytes to store that data. Correct. Now next address for LC3 would be, what would be next address? It would be 4 and so on. The information would be getting modified in the symbol. Now let us say our section.data is over, our section.bss is over. Now we are seeing section.text. Now we have to come back. We have to now talk about this IP. Now IP would be, our program counter would be initially 0. So let us start the procedure. So we got global main. So we enter this main into symbol table. Now check main whether main is there or not. Now suppose let me create an error here. Suppose if say I see that I have main added there. Correct. Now let us see what exactly it does. Now you will see an error. Label main inconsistently redeep. That means what? While it saw main, it added first into symbol table. Which main? This main was added in symbol table. Correct. It added the value to that time. But when it reached here in the section.text, then it identified again main. It is trying to search into symbol table and it found that main is there. That's why it displayed this error, inconsistently redefined. And it says where was main defined? Was defined in line number 4, and line number 4 for me is this above. Correct. This is the line number 4. So 1, 2, 3, 4. Correct. So that's how the variables also would be verified from the symbol table. Now we got an instruction pointer. Correct. So now instruction pointer is 0. So main address is 0. So next code that it is going to get, is, say for example, okay, let me reopen this file because I made the changes. It is here. Okay, now let us use this here. So I got now first extern printf. So I got printf. So now I will enter again into print that thing like symbol table. Now symbol table is not having any value. Now this is, though IP is initially 0, but I haven't assigned it to anyone. So now I got main and printf right now. Main is said to be defined one. Okay, because it is said to be global. Now suppose if I write global main and if I write here main1, now see what happens. Has it translated the code? Yes. If I check the symbols available in my symbol table, okay, readlf. You should, sorry, readlf -s. You should see main and main1. See main1. Now main is not seen because main is not defined, though it is said as global, but definition was not found. So that's why it is not added here. Even if I use nm for this file, I should not see main there. Can you say that main? No. It was said to be global, but until unless I get main's definition, it would not be added. Is that fine? Any question, query? Yes.
No, sir.
Okay. So I'm assuming that you are generating file side by side, that object file, while you are reading, because what we did was, if I see this LST, actually you are writing this. So you are reached here now. So nothing would be done. Nothing would be done. This printf would be added there because we saw printf was added there, correct? External printf. So nothing was added with printf. Now it get main. Now when it sees main, it will add that into symbol table with status to be defined now, correct? Now if I remove this, say for example from here, that the change that I made, I will remove that main one now. Let me translate this. Let me check the symbol. I can see that main is added and it tells in what section it contain, what it is there and what is the address of it. So my instruction pointer address 00 was given to main. Correct. Now suppose if I make the modification. Suppose I add this. Now what happens? Let us translate. Let us see. Now you will identify that main is not 00 now. It is at 2. And what was at 00? This JJ, which I declared there. This I declared there, correct? So depending upon after this external and global, whatever it gets, it would be getting value as 0. And add like this would be 0 and 1 because this instruction requires 2 bytes. That's why 0 and 1 byte is used. And now second byte would be given to this main. Is that fine? And that is the reason why we can see that that address was given to here as well. So automatically my instruction pointer should be modified from here. Okay, so let me come out of this and let me go here. So my instruction pointer was 0 for this JJ. JJ was added in my symbol table. Now symbol table entry earlier was where LC1. Na? We used LC1 for data section. Yeah. Now for text section, what is the symbol table? I can make use of uh, in continuation LC1 only because it is going in data section because it is defined. Correct. So wherever it stopped earlier, so it stopped suppose at 28 and we identified that 28 like if I open that LST, this was 28, 29. So now my next symbol, what should be the number? Should I add that into the one table? Now I'm not going to use LC because LC1, LC2, LC3 are meant for specific one and for code perspective, I'm going to make use of this IP. Correct. Now this IP 00 would be used while I am reading this text section. So this is an internal adjustment made by me because I have to, if I don't use this, say for example, LC1, LC2, LC3 and IP, if I use all of them to be LC, location counter, how will you identify which is at what place? Because addresses are different. It starts at 0, this starts at 0, this starts at 0. So how should I differentiate which section that particular symbol belongs to? That would be very hard for me in that situation. Am I right? Correct. So then I would definitely have to find a solution and that's what I did. So ultimately what you did, you tried populating the symbol table. So you started with JJ, you got JJ, you added 0, then you are getting main, then you are adding main, then you are moving further. And side by side, you are generating an intermediate code the way that I showed you in one of the class, like opcode number, symbol number, and this literal conversion. So literal conversion, whether you want to do at on the spot or whether you want to do it by storing a literal table, that is your decision. Correct? That is your decision. Is that fine? Any question? So ultimately what happened is we added this data and we added intermediate code for this along with these addresses, because how we compute the address of next instruction, because our opcode table will have a column called size. Opcode, what is the size, number of bytes required for translating that instruction, depending upon what is used there, whether it is a 8-bit, 16-bit or 32-bit element, a register or memory location. Is that fine? Any questions till this? Yes, please.
No, sir.
Okay, I assume now you have intermediate code with you, correct? One of the class I showed you how exactly you are going to write it. Am I right? Can you recall how was it? How exactly we wrote it? If you recall, on 18th lecture, you can open through, say for example, open the file 18-4-2022. Let me open that from here. This is the file. Okay, on 18th. If you see that file, actually I added this opcode number 89, register number 1, register number 4, what is the size, how many bytes it is taking, and so on. Correct? That's how we added that. And this instruction probably requires 5 bytes and so on. This is a sample case that I described that day. So your intermediate code will have some form like this. So you may use the here OP89, OP hash 89 even. For example, if I want to use open this, like I can write this as OP hash 89, which tells me that it is opcode number 89. This is register number 1, register number 4, literal number 1. If at all you are adding that there. Is that fine? So this is how you are going to generate the intermediate code. Now suppose your intermediate code is generated, whole symbol table was modified. Now you try to find out in symbol table whether all entries are defined or undefined. Correct. Now whatever is written as extern, that each thing would be defined one. Sorry, undefined one. You are not going to really worry about that if it is written as external. But if it is with global, even you don't care for a while, because we saw when I made change as main to be global and main one to be the starting variable. Main one was taken into consideration, but main is not taken. So global and external, you are only going to add the entries there, nothing more than that. You are not going to add you are going to add you for only external thing. But for global main, nothing is done. Only it is telling you what is the starting point. So you can skip that. Only keep information that your instruction pointer should start from main. That's what we have to communicate, because execution will start from main. So if you see, I made the change in my code, correct? Here I added that JJ, if you recall. Now, though I am saying this, my execution will start here, but my code translation is from JJ. So if I translate this code now, and if I generate that lst dash l p dot lst, now my code actually has this written, but when I start execution, so let me start, let me write gcc and let me show you. Now our address, our execution should start from, where is gcc? gcc 1702.o-m32 g dash f dwarf. Sorry. GDB. If I say run, actually it started from main. Now if I write breakpoint, suppose if I don't if I specify say breakpoint to be JJ, when I say run, from here where it started, it actually started from main only. It hasn't started from JJ because JJ was not the thing which was communicated to the system. What is the starting point? Correct. If I quit from here and if I write say breakpoint main now, and if I say run, now it is waiting for me because global main was specified. Is that fine? Are you with me? Are you there? Siddhi, understood what I tried to show here? Siddhi, am I audible?
Yes, sir.
Yes, sir.
What I said? Like see, suppose if I have written my code like this, my code says execution should start from main. That's what this global tells. Now first line in my code is JJ colon XOR EX. Now when I create an executable and execute it through the debugger, or even it I execute, if I execute it from debugger, it executes successfully. Now when I write breakpoint to JJ, mean execution should start from JJ. That's what I'm saying. But my system communicated to the executable that you have to start execution from main only because it is written as global main. So if I say run, my program started with this. So if I suppose display $EAX and if I say run, nothing was shown for EX. Now if I say breakpoint main, now let me sorry breakpoint main display $EAX and if I say run, now see X or EX was not getting executed because my first statement was what in my code X or EX. So EX should have been made 0, but it never entered, never took address of this JJ under execution for program counter. Correct? So it started from here only. Now if I make a change in my code and if I add here this X or EX, now EX is a garbage value. Now this is the first statement. Now see the line number. Actually, JJ was defined at line number 11. You can check this. See JJ at line number 11, but it is executing line number 13. Okay, if I say step or NI, it made EX as 0 because it executed this statement, not this one. This will never get executed until unless I have code written which says jump to JJ or somehow I am controlling execution from jump to JJ. Then only it is going to happen. Okay, let me show that part also to you. So let me modify again the code and let me write JJ here as return. And here I will write jump to JJ. Fine. Let us assemble. Let us compile, create link executable. Breakpoint run display $EX. Now see, and so let me write step. So see, the code is getting executed. EAX is still 0. Now 4, 8, 12. This. Now multiplication happening. Now it is printing. Line number 38. Now this 20 seems to be printed. Now return value with EX is 17. Some value we don't know. Jump to JJ. Now it is going to JJ. See that line number. JJ or EX. EX is made as 0 and return. So until unless I specifically tell system to go to JJ, it will never execute JJ statement X or EX, X and rate. Is it fine now? Understood? So what is the importance of that program counter, which we said we are going to use subsequently like this. The size would be added every time whenever you are reading one instruction. When you go through one instruction, you got second instruction. Now size would be added in the instruction pointer so that address for the next is given. That's what it is doing here. Say for example, if I open that p.lst, you can see here. So it got 2. So 0, 1, 2, 2, 3, 4. So 4, 5, 6, 7, 8, 9, A, B, C, D. Next address is E. E, F, 10, 11, 12, 13, 14, 15, 16, 17. That's why 18, 18, 19. That's why no 18, 19, then 1A. It is not 20. 1A, 1B, 1C, 1D, 1E, 1F, 1F, then 20, 21, 22, 23. Now 24, 24, 25, then 26, 26, 27, then 28, 28, 29, 2A, 2B, 2B, 2C, 2D, 2E, 2F, 30, 31. That's why 32, 32, 33, 34. That's why 35, 35, 36, 37, 37, 38, 39, 3A, 3B, 3C, 3D. Next is 3D. Correct. 3E, 3F, 4A, 40, sorry, 40, 41, 42, 43, 44, 45, 46, 46, 47, 48, 49, 4A, 4B, 4B, 4C, 4D, 4E, 4F, 50, 50, 51, 52. Now my code is ended here. Correct? And that's how it would be computed. So this instruction pointer would be used by you. Now what is to be done with next pass? Like we have intermediate file. So this is where our first pass completed. Now in first class of a 2-pass assembler, if you identify any entry in the symbol table to be U undefined, then you give an error. Okay. Likewise, say for example, if I make the change here, if I refer here as sum 32. When I translate this, so while generating, it got this sum 32 error. So this was because we made the changes in the code. That's why, like we added sum to. That's why it is showing these errors to us. Okay. So rm star.o. So when I remove that sum 32, automatically the remaining errors would be changed. Is that fine? So actually what exactly it is doing? It is trying to verify. So this will never generate an object code. So if I try to see star.o, my object code is not generated because there are errors. That means it never moved beyond intermediate code. While generating intermediate code, it identified that that symbol table entry for sum 32 is undefined. That's why the error was shown. Correct? Any question? Any query? So now with assumption that all entries except extern are with D defined, there is no entry other than extern to be undefined. Then we have intermediate file ready with us. In next session, we'll try targeting. If I have been given an intermediate file, how can I generate an object code from it? Okay. So if you, I don't know whether do you have any questions, because nobody is responding until unless I ask. So I'm assuming that you understood this. If you haven't, if you are in Pune, if you are in the department, you definitely can come and discuss with me if you have any queries with respect to this translation. Note that you have to define your own or design your own assembler, a two-pass assembler.